Turn on the main power switch. Turn clockwise. Turn on the ignition key switch. Instruments light up. Digital meter lights up. Fuel pressure gauge. Vacuum gauge. Oil indicator light. Frequency conversion indicator light up. Now start the engine. Turn the key switch clockwise. Fuel, pause, indicator lights light up. The digital have changed. The accelerator pedal is in this position, and the foot gently presses the pedal. Accelerate. The engine starts up. System check fault simulation. Measure with a multimeter. Turn to DC 20 gear. The first fault is the 4-cylinder fuel injector fault. The 4-cylinder fuel injector is here. When the key is turned on, we measure the 4-cylinder fuel injector. The voltage value is 12 volts. Then we disconnect the fault. The voltage becomes 10 volts. Indicates a fault. Then we start the engine. The engine has a shaking phenomenon. Restore it. Disconnect the shaking. Restore. The second fault is 1-cylinder fuel injector fault. Measure the voltage value of the ground to the 1-cylinder fuel injector is 12.8 volts. Turn on ignition switch. Disconnect fault. Becomes 11 volts. We start the engine. Engine shakes. noticeable shake. The third fault is VG fault. We measure the voltage value, which is 0.8 volts under normal circumstances. After setting the fault successfully, it's 0 volts and restored to 0.8 volts. Start the engine after disconnection. The engine cannot start and the intake volume cannot be detected. We restore the fault. Start the engine. The engine can run normally. The fourth fault is VTAETT temperature sensor fault. We measured its voltage value and it was 1.5 volts. The voltage value changes according to the temperature. The current temperature is 1.5. It may be higher if it's cold. Then we disconnect it and set the fault. The disconnect fault is 5 volts. This is the throttle fault. Under normal circumstances, we step on the accelerator pedal. It changes. Now there is a fault code. We turn the key back on 0.99 volts. Then we step on the accelerator pedal. The voltage value changes. We disconnect. It's 0 volts. We step on the accelerator pedal again. The voltmeter doesn't change because the throttle valve detects a fault code and won't work. Note here, there is a fault. The throttle valve won't move. We need to restart the key switch. It's still the original 0.99 volts. We step on the accelerator pedal and the throttle valve are back to normal. The fifth fault is EVE fault. We measured its voltage value as 0 volts. We set the fault to 5 volts. It's a camshaft voltage fault. We start the engine. The engine is not working so well. We restore the fault. Start the engine. The engine is obviously powerful and strong. It can detect the phase. Intake temperature THA fault. Under normal circumstances, it's 1.54 volts. We just measured it and it was 1.54. Then we disconnected the fault. It's 0 volts. Restored to 1.5 volts. As the temperature changes, the voltage value changes. This will not have a big impact on the engine in the short term. The seventh fault is G2 fault. Under normal circumstances, it's 0.8 volts. After we disconnected it, it's 0 volts. Camshaft phase disconnected. Starting the engine should not work very well. It's obvious that the engine power has risen and is running normally. The eighth fault is the water temperature fault. Its voltage value is 0.7 volts. The voltage value also changes with the change of water temperature. Generally, it varies from 0.2 volts to 4.4 volts. Now the water temperature has dissipated and the water temperature gauge has come up, so its voltage value may be a little lower. Disconnect the fault simulation, its voltage value is 0 volts. The water temperature has a fault. The electronic fan is rotating and working. We restore it. The voltage value is 0.7 volts. The operation is completed.